This is an example of an equation of a straight line, and it's very useful when it's written in this form. In particular, it fits the template y equals mx plus c. And because when it is in this form, the number in front of the x represents the gradient of the line, and the number on the end represents where the line crosses the y-axis. A positive gradient means the line is climbing, and a negative gradient means the line is falling. And the larger the number, the steeper the gradient. The number in front of x is 5, so the gradient is 5. The number on the end, c, is plus 4, and so this line crosses the y-axis at plus 4. Here's an example of a straight line graph with its associated equation. This is in the correct form, y equals mx plus c. So m, the number in front of the x, represents the gradient, and here it's plus 2, so we can see it's climbing. The number on the end is plus 1, and we know this is where it crosses the y-axis, and here we can see, as we expect, it crosses at plus 1. Here's another equation of this straight line, and here we can see this time the number in front of the x, 5, represents a gradient of 5, and it is steeper as we expect, and the number on the end, plus 1, it crosses the y-axis at plus 1, exactly the same as the other line. And finally, here's one more. Again, it's in the correct form, y equals mx plus c, and m, which is the value or the number in front of the x, is minus 2. And it's minus 2, so a minus shows that we're falling. The line is falling away, and again, that's true here. But again, it still crosses at plus 1. Have a look at these two equations. They're in the correct form, y equals mx plus c. So I'll look at the number in front of the x. The gradient is 2, it's positive 2, so we're climbing up. And that's the same for both of these. They're both climbing up, and the same gradient as we can see here, so they're parallel. But remember, the number on the end tells us something very useful too, where it crosses the y-axis. So this one, plus 1, I'm expecting it to cross the y-axis at plus 1, and it does. Whereas this equation, I'm expecting it to cross the y-axis at minus 1, and it does. What if you had a straight line, but you want to find the equation of the line? Well, the first thing we're going to do is find the gradient of the line. We start by picking 2 convenient points on the line. And they can be any 2 convenient points. I'm also always going to pick whole numbers. So I wouldn't, for instance, want to pick this value here because it would be awkward to find what the coordinates of this particular point was. So I'm always going to pick something that's in the crosshairs, if you like. So I'll pick these 2 points here. And then we're going to use this formula that allows us to calculate the gradient m. It's changing what is a fraction, and we're going to, on the top, we'll put how much the y value has changed going from one point to the other, and on the bottom, how much the x value has changed going from one point to the other. So I'm just going to put the coordinates in here. Now, how much has the y value changed going from this point to this point? Well, the y value is minus 3, and it goes up to 3, so it's increased by 6. How much has the x value changed? Well, we've started at minus 2, and we've increased to 1, and we've increased by 3. And then for now, you can just put this into the calculator. You'll probably be able to do it in your head. Plus 6 divided by plus 3 gives us 2. So the gradient is 2. Now, obviously, it's taken a little bit of work to find the gradient, but finding where it crosses the y-axis is very easy. We can see immediately it's at plus 1. So we know that C is plus 1. And remember, in our equation, our template, it's always in this form, y equals mx plus c, where m is the gradient and the number on the end c is where it crosses the y-axis. We've got everything we need now. We can substitute in our value of m, substitute in our value of c, and we've arrived at the equation of this line. We'll do the same here. So the first thing we're going to want to do is find m, the gradient. So I'm going to pick two convenient points on the line. This one looks good. And you've got choices, but I'm going to pick these two. For instance, this is a nice point right in the crosshairs, and I can just sneak this point here again, but I've picked these two. And then I'm going to use my formula, which in the end you'll have to memorize, but it's a fraction. And I'm going to look at how much y has changed going from one point to another, and how much x has changed going from one point to another. I'm going to make life easy for myself by writing in the coordinates. And I should also point out, it doesn't matter. I can go from this line, from this point to this point, or from this point to this point. It doesn't matter. But once you've made a decision, you've got to stick with it. So I'm going to go from, this is my starting point, and move to the lower point. So my y starts at 4 and ends up as -2. So the height has gone down by 6. Now my x value has changed from -1 to 1. So it's actually increased by 2. And again, we can just put this in our calculator. -6 divided by +2 is -3. So we know that the gradient, in other words, m, is -3. But again, finding the value of c, which is where it crosses the y-axis, is easy. I can just look and I can see straight away, oh, here we are, crosses at +1. So once again, I've got everything I need using my template to write down the equation of the line. I know that m is -3 and c is +1. And there we have it.